the idea of this session is to go into exploring what would make an ideal platform as a service. So what we've got obviously a few implementations. We've got the one Heroku did a presentation earlier. I was just involved in one where we did one on Cloud Foundry. But both of these, they're very early stage implementations. So we want to discuss the ideas and topics about what changes you could make to these platforms as a service, what features you need to support, what's not really compatible in order to get to the idea of platform as a service early. So I guess we can kick off straight away with the first question, which was what can a platform as a service do to make Erlang deployment operations easier? Thoughts?
So I actually missed that Cloud Foundry talk. I know Heroku has build packs, which is a way of grabbing a pre-compiled copy of your language runtime, like OTP, R15B, or whatever, and then installing that and using that to compile and run the code that runs on the platform runtime. I'm assuming Cloud Foundry does something like that.
Cloud Foundry pre-installs all the runtimes into the machines.
Right.
And then actually end up symlinking all the applications to make sure things remain compatible. Because one of the key differences is that Cloud Foundry gets all the build to be done locally on the developer machine as opposed to having a specific build stage.
Okay. So yeah, I guess Heroku's answer is build packs. The bit that we don't have a great answer for is how do you compile, how do you keep up with changing OTP versions? Like if you want to run variants like Costas's LLVM thing and so on. I guess, yeah, like Heroku has a compile thing, which is git push in and little file system container out with the app and runtime necessary to run the thing. So that automates some parts of it. There's still maintenance hassle around actually maintaining the build pack sort of script plus precompiled binaries for it. So yeah, like running multiple versions of Erlang means you've got to like have multiple precompiled versions of Erlang sitting around somewhere.
Well, I think one thing that makes Java popular in this space is the fact that you get these Matryoshka style applications where everything that basically defines your application is bundled up in one little bundle, and then you just drop it in a directory and boom, it's live. And if you think about it, with an Erlang release, we're pretty close to having that, right? We've got most of the pieces there. We just need the automation around actually making it live in a real hands-off way.
So do you guys think we should be producing images that contain like an entire OTP plus the application code and everything, like a self-contained, don't need anything else, this is the image that you can execute and run? Or do you think that we should share binaries and OTP stuff between different applications on the same version of Erlang? Like what's the...
So I think the complication is the trade-off between actually having it all run easily. Like if you bundle everything together, it's just going to work. But if you actually include the whole of Erlang, it obviously ups the size of the binary to move around. Like I noticed the slug on Heroku is something like 65 meg,
it's a pig.
Which is not huge, but it's still a lot to be copying around given that what most Ruby slugs are 4 or 5 meg.
Yeah. But so we've kind of, this is something that we've run into since we added the build pack stuff. Like we're running Ubuntu on the base machine, and we've got a bunch of languages that come pre-installed as like Ubuntu devs or whatever. So if your language pack targets that environment, then you're cheating. You're using like pre-installed copies of stuff. And the ditto for like C compiling things. If you had to have I ran into this because I managed to write a build pack that more than 10 minutes run, so I got killed by our infrastructure. We went, no, that compiler's out of control. Nothing takes 10 minutes to compile. You only ever do Ruby apps. But the thing is, like, if you had to like build GCC or some kind of non-trivial application plus its compiler and its SDK and all of the things, and those are big compiling jobs. So, I don't know where I was going with that, to be honest. Let's move on.
So you were asking that it's the choice between limiting it like per application for the developer. For us, I'm not going to encourage somebody to have like general Erlang install. I want the specific thing that I need to be deployed upon it. So I want PaaS that limits choices.
Yeah.
Yeah. So for an application, and that's why something like I want fewer choices. I want control. Somebody may want a more general environment that they can do multiple things on, but when it comes to something like React, lock it down, limit choices, because otherwise you're just pushing problems up the stack to the application provider or the application builder. So simplicity is better for us.
So, because I guess the thing is that Heroku's previously always had the policy of having things pre-installed, right? Like the Ruby runtimes are all baked in.
So the problem that we came to with that is that even within the Ruby community, and this happens in every language that we've looked at, like different customers want to be running different versions of any given language. Like Java, you don't know whether they want Java 1.5, 1.6, 1.7, 1. Whichever. You don't know which container stack they want to be running, and so on and so forth. In some communities, some of these issues are kind of settled, in that there's like one popular stack that you can basically pick. But if you want broad support, then you've got to have some mechanism for somebody to be able to get around the needing things pre-installed problem. And so yeah, like we currently have that, and it results in fat, compilation slugs, outputs, whichever.
If the premise is how we can make operations easier, PaaS can make it easier. Does that make it easier? That makes it easier. I mean, it gives you choice, but it increases complexity.
The way we've done it, it makes life difficult for the build pack maintainers. But once you've picked a build pack for an application, you generally don't change it, and you do have the option of like making the build pack so it is using some precompiled resources that it just adds into your slug. So then you can, like, if you use that build pack, you can say, well, your compile version and your OTP version won't change if you continue to use this pack.
Presumably a risk you also run with doing it that way, though, is like even just the build pack approach, like going to there, is if you're assuming you might run that on a slightly more private cloud where you've actually got an operations team that's usually used to being able to very much control what it is that's running on their infrastructure. You've got to this point that you could be running a version of Erlang that they don't see as being appropriate for their infrastructure, for instance. It may not be optimized for the right ways. They like to have some kind of custom modification applied to it and things like that. I guess kind of in the
So the assumption is making it easier for the consumer of Erlang, not the operator of the system or the operator of like another layer apps across it.
Yeah.
The assumption here is what makes it easier.
Yeah.
Certainly, just adding build packs does not make it easier for people developing apps unless somebody has written a build pack for the thing that they actually want to do. So if that's the case, then yeah, build packs are a win. Otherwise, no, because now I want to build my application on Heroku. Great, I have to go pre-compile Erlang, write a build pack, and then write my application. So yeah.
How many people are doing that instead of just taking the existing ones?
Most people use existing ones. It's the kind of bleeding edge people in different language communities are the ones who tend to write.
There'd be more adoption if they did it more like the Java app?
So the build pack support has actually been essential for Java for the different JDK versions. Like there was no obvious way for us to support like multiple Debian installs of Java on a single machine. I could be wrong. I don't really look at the Java stuff too long.
Okay. Well, I might start on the next question. So I guess we kind of covered this one a little bit, but So the idea of the preparation of the code, so obviously it's the build pack approach there versus Cloud Foundry, build it before you upload it. Do anyone else have any thoughts on that one before we kind of skip over it?
So how do you take into account the major providers? I mean, how many major Erlang services or applications are provided on PaaS today? Maybe you've got a RabbitMQ or something, but do you take into account the requirements of the various systems that are going to be built on top of it, like React and Rabbit? Or
yeah, so obviously I think React continues to be like the gold standard for what people aim at. If they can get that running on top of an Erlang PaaS, then you've probably got enough support for it to actually do anything.
How
I haven't seen any of them quite reach that yet.
Yeah, how many people can put their hands up to that right now?
Like I think the complication often ends up being because Erlang quite frequently mixes in C code. So it's at that point you start becoming very platform specific if you build that code. So that's I guess why the build pack works there. But it has the thing of there's a lot more work to do at deployment time.
Yeah, and it works because we have like one flavor of runtime container, which is the same flavor that we build in. Yeah, I don't even know what I would do if there was some kind of like cross compilation necessary or something.
Yeah, so Cloud Foundry's approach to that is that we symlink out the libraries to try and cheat around it. But if you deploy anything with C inside it, it's going to go up horribly. Okay. Okay, so the next one is what Erlang features don't fit with the PaaS?
I think the obvious one that we've talked about at Heroku is hot upgrading code, because nothing else that we can see has really a concept of doing that. Like if you deploy a new Ruby thing, like I mean, even if you were running, maybe you could do this if you were running like a PHP in a container and you could drop new files into the container somehow.
That's what most exploits do.
Right, yes. So we want to enable exploit as a service in the cloud. So how do we go about this? Yeah, I'm not sure. Like in Erlang's case, I think the path to this is kind of sideways, in that once you can get an Erlang distribution into your running cluster, or at least you can get some SSH session to a shell for your running cluster, then you have a way of loading code into the cluster, and you can do it sort of sideways. Because I can't think of any other language where this is a feature that they're even thinking about. And our platform has no concept of that as a first-class action to take. We have an idea of building things. We have an idea of like a release where we replace containers of one version with containers of another version, but we have no concept of like a container with this version that we then modify.
Yeah, we our biggest production environments, whether it's customers that join it or it's like AT&T themselves, you talk about this and it's like you think you have the coolest thing in the world, and there's no operational awareness. They don't register what you're offering them, and we think it's cool, and we can demonstrate that it's cool if we can control the entire environment. But the minute they want to take control of this, it doesn't fit into the sort of the paradigm that they're used to operating on, so they don't care about it. That's something. How big a cluster are you talking about there when you talk about clusters being run? What are the size of the clusters?
We have today, at Heroku, we have one coherent Erlang cluster, which is our Logplex application, and that thing generally runs at about 12 nodes.
Okay.
And we do live version upgrades on that. And yeah, again, it doesn't really fit into the same release strategy that we use for, say, the HTTP routing stack, which doesn't operate as an Erlang cluster. Because that thing we upgrade and replace nodes node by node. The Logplex cluster, we can write some shell code to upgrade a node and then just run that on RPC multi-call upgrade.
So what would prevent using app up files? to kind of deploy the second version of the code over there and then tell them that to do. Like, that's what that mechanism is for.
Hands up in who in the audience has successfully used an app up.
I don't think anybody ever has.
I mean, it's kind of a little bit trolling, but kind of also, they're super complicated. Like, one of the things that I've liked in recent years about actually developing Erlang systems is rebar, and how it's taken a lot of the like manual editing files for things and figuring out how to do stuff, and like it's taken a lot of the pain away. And I feel like app ups and rel ups, they work for the use case that Ericsson has, and I haven't encountered them as something that solves a problem that I've had without just introducing way too much complexity. Like I can write Erlang shell scripts to upgrade nodes far easier than I can write app ups and rel ups. So I guess even if like Heroku tomorrow offered a way for me to like inject an app up or a rel up or some kind of bundle like that into the system and have it upgrade my nodes, I'd still probably just really want a shell where I could log in.
Well, it seems like app ups and rel ups are really kind of targeted at big systems with really complex upgrade requirements. And you know, for most applications the size of which I normally interact with, it's not that complicated, right? It's like, oh hey, we're gonna, you know, we just need to inject this new code. And if you're going to do something like introduce a gen server with different state, you just restart.
Yeah, yeah. Because of the way you architect your systems for availability and reliability, like some kind of input load balancy thing in front of it, up in front of the thing that needs to be upgraded, you generally have the option of punting and rebooting nodes anyway.
If you're talking about infrastructure run PaaS, you know, your infrastructure run PaaS and services that are based on Erlang. I mean, I'm surprised. So the biggest you've seen is 12.
Well, so I should probably point out that you can't run Erlang clusters as a Heroku customer today.
Right. Well, okay. So I think one thing that we're seeing, and I wish Fritchie was here. He's wise to avoid when I talk, but. Like when we, with some of our biggest clusters now, you know, Matt Rainey probably, or Greg Burke could talk eloquently about the OTP-isms that are becoming really costly on the bigger clusters. We're talking hundreds of nodes. So, you know, you get, you know, the cost of the communications and, you know, the whole, the degradation of some of the performance. It becomes, it's predictable at least, what you're seeing. But you know that you're reaching a bound of scale. And so people have made other choices for even bigger clusters. And that's what we were talking to Francesco about this week, about other choices we can make.
Alternative Erlang distributions, or
yeah.
alternatives to Erlang distribution.
Yeah. Yeah.
So, not to derail the conversation too much, but how compatible is the idea of an Erlang cluster with a PaaS?
I mean, I think it should be doable. The main feature I think we're missing is container-to-container networking. If we added that, that would pretty much solve most of the problems.
Because presumably nothing could stop whatever's managing your cluster of nodes, essentially introducing each node to each other as it's brought up.
Yeah, yeah. We just haven't properly virtualized the network. And that's the problem. We're running on top of a network that we don't do anything complicated with. The network does not know about the networks that we would logically introduce, like one per app, or as a resource that you can attach to multiple apps, or specific kinds of containers inside an app or something. But yeah, we don't have that, and that's why we can't do it right now. But you know, there's nothing stopping anybody from going out and building it. Then some of the other talks at the conference look like they would help out with that a lot. Holger's OpenFlow stuff looks really promising to me in that regard.
So do you think So in that respect, right, so you get these containers that are talking to each other. Do you think it makes more sense to just kind of assume the Erlang OTP distribution, or do you think maybe it's just like, okay, these nodes can talk to each other, you figure out how you want to pass those messages across?
I think as a first pass, we want to let people do distribution the way they've always been doing it, so that you can run existing Erlang applications that know how to cluster, like you know, eJabberD and Riak and so on and so forth. The performance is probably not going to be anything like what you would get out of a dedicated hardware and software stack, but you know, that's not what you're going for with the PaaS. You're going for the sort of management and deployment aspect of it, I suppose.
Presumably the complication with telling people they can do it their own way is how you discover what the other nodes are. Like if you've assumed that you're going to use an Erlang distribution, then it can actually do the net ADM commands to actually connect your nodes together as new ones get booted up. Whereas without that,
Yeah, because then you end up with a PaaS-specific distribution. Right?
yeah.
Right.
But even if it was your own library, the PaaS then needs to start supporting how do you introduce nodes across all these, and yeah, you might end up with some kind of PaaS-specific discovery service you need to talk to.
Yeah, I mean, I think people have run into this on EC2 exactly. I mean, somebody wrote Node Finder. I forget how that is. I guess Erlang distribution, aside from DNS and world files or something, it has no multi-machine discovery right now. And the multi-machine discovery it has is really weird and like not helpful. So, I mean, I would not use a world file if I was going to introduce Erlang machine distribution. I mean, people build their own mechanisms, whether it's like config files of lists of nodes, or you know, they have some shared resource that they will connect to anyway. Like, you know, you write keys into Redis with host names, or there's some predictable host naming scheme. Or, you know, I've seen all kinds of terrible, horrible solutions that we should probably improve on.
So we covered this earlier into it anyway, but let's move on to the next one. Obviously, we've talked about the first two already, but what about Amnesia in terms of supporting it? Like that's obviously built a little bit on top of the distribution, but then there's also the whole concept of disk nodes and whether they're at all possible.
I love Thanks. I love when Amnesia's out there because they're eventually going to find a bunch of problems that we come in. You know, actually, it's hard to get Amnesia out of a dedicated Erlang programmer's hands when they live in Europe, I think. You know,
We solve different problems.
you guys got to stop doing this. We've got a perfectly good persistent database. So, I mean, if you want to. I mean, so part of the question of this is, I mean, are we trying to shoehorn Erlang in because we all like Erlang and PaaS? I mean, it has a couple of things it can do, but they're sort of not narrow. I mean, you can make it do a lot of things, but you know, with hot code upgrades, people don't even start with a operations paradigm that allows that to be to think about it. Unless you've got a full Erlang application, we can do that for somebody. If like somebody's running a system and they say, hey, we want to do a upgrade because we patched something, and we'll say, okay, we'll help you do it. Like, you know, Grant's here, he's done it a couple times, you know, and that's useful, but people don't embrace that if they're not already sort of aware of what Erlang has. So how can we take more advantage of it? I mean, really just becomes more like awareness of the language and people having an operational paradigm that actually brings that in. Now, if we're talking about people using a PaaS, that's more difficult to get people, because you get a generic audience of Ruby developers, or they want all this stuff transparent. For the people operating a PaaS, it depends on how critical the system is and how many things you have on Erlang. I like it. I think if uptime and quality of service are important, and you have the sort of underlying resources to ensure, you know, sort of a stable quality of service as you go through different sort of step function events, upgrades, or, you know, code changes or whatever, that's a great thing to have because it looks pretty smooth. And at Akamai, if we had, you know, that was a cool thing. If we had Erlang, you know, if we built it like that would be a great thing when you have, you know, big clusters or big regions and you want to do upgrades. It would be a pretty cool thing to do instead of bouncing a whole region. But and you know, it doesn't. I mean, are we trying to make it fit when it's such a outside the normal? I don't want to be contrary. I think it's cool, but and we use it to good advantage. It's probably just knowledge of Erlang.
Well, I mean, it almost, that's a very good question, right? I think we're all kind of a little bit biased.
To be fair, I'm a lot biased.
But I almost feel like it's not quite mature enough yet. We're still kind of finding our way through a lot of these issues. Erlang has a little bit of a bent towards doing things a certain way because of where it came from and the way it's been used. And I almost feel like you kind of have to, maybe in 2 or 3 more years, this conversation turns out quite a bit differently.
Distributed processes and node communication. I mean, that's.
I'm willing to be kind of cover some of those already.
Yeah. I mean,
so
and then you have amnesia up there.
Yeah.
You want to cover that, Francesco?
Well, I'll talk about amnesia. I have very strong opinions about it. 2 answers. One is that if you had the container-to-container networking that would let you establish Erlang distribution, then you can run amnesia. Problem solved. The second answer I would have is, God, no, don't run amnesia. And the thing is, amnesia relies pretty heavily on node identity. And if node identity changes, frequently your containers don't have persistent disk. So you don't have any disk or disk-only copies.
Are there any platforms as a service that provide disk?
No, I mean...
I think it's just you can generalize to, not usually, they just don't.
When you take XD1, it has its own backplane, you won't get network access, which is the biggest issue with Mizia.
And then, there are a lot of operational issues to running amnesia on a non-reliable, frequently changing network with different node identities that make it a real giant hassle. And frankly, we are trying to take, for the operational hassle alone, we're trying to eliminate our use of amnesia.
So I guess that pushes more generally to applications as well, that node identity is something you kind of have to let go of or be a lot more flexible on.
Yep, because they will come and go all the time.
Well, I don't think it's at all unreasonable to say that in the space of applications that you want to run on a PaaS, if you're going to do this with Erlang, there are certain things that you can do that we're just not going to support. Amnesia is probably one of those things.
Yeah. I guess the overall question is, obviously the PaaS for a lot of other languages, like Ruby being the key one, people have seen massive benefits. Like a lot of people are considering deploying their application as the only way. So the idea here is, can you get Erlang to that level? How many features do you lose along the way? It sounds like the answer is probably quite a few of them. But
well, and you have to do things. You have to do things differently.
Yeah.
Right? I mean, when you talk to people about, for example, Heroku, you say, "Why is Heroku great?" They're like, "Dude, 5 minutes and it's up." Right? It's like it takes me longer to name the Git repository than it does to bring the application up. Right? And that's the kind of, and it's easy, it's simple, it's one step. Bada bing, bada boom, done, right? And we're not there yet with Erlang, right? Even just bringing an application up on your local box takes a little bit more than that. I think Rebar has helped in this area a lot because it's less the wild, wild west now. Rebar says, hey, if you follow these rules, I'll make things a lot simpler. And that's helped, but we've still got a ways to go.
Yeah. I mean, if there was, so Rebar establishes some good conventions that I personally can live with, which is why I'm using it. Because I've seen alternative build systems that sort of encompass the same functionality as Rebar, but they make choices that I haven't been able to live with. So Rebar has done that for the build process, but some of the things like Rebar Generate and RelTool are just so not ready for prime time that it's painful. Like, I really wanted to use the Rebar RelTool thing because it generates allegedly relocatable, releases containing your app code plus OTP plus your dependencies. Fantastic, that's exactly what I want. to be to prepare my runtime images for deploying Erlang systems, except that there are so many constraints on the precise environment in which you run that command, and your project structure has to be different to the default thing that people do when they set up their project structure, that I'm just like, nope, I can't use it yet.
Well, you know, I think the Rebar team's done a pretty good job of automating what is kind of an ugly process, but it's still an ugly process.
Yeah.
For us, it's you know, at a small enough size, if you're willing to make some of the compromises, a distributed database on a PaaS is a compromise. Is a compromise that has costs that are higher than the Erlang part of it. But then as you get bigger, even if you go down to bare metal or zones or something like that, you know, where you sort of get out of the real idea of what PaaS is, Erlang becomes the issue. It's in some important, well, not Erlang, but the current major distributions. You know, we're fighting against some of the things. And so it's
like the, say, Ubuntu packaging of Erlang or something else?
OT.
Oh, OT. Okay.
So you get 200 really high concurrent writings. It's really high concurrency, high write load. It's, you know, you're paying a price for that distribution. So, so for us, maybe if we had a different model, because we're doing distribution, you know, we're using some of the things that Erlang gives you, but we're also sort of taxing the virtualized environment as much, the behaviors of the data. So, I mean, we just, how can we take full advantage of Erlang? And we just had another conversation about how it doesn't seem to fit some places.
I put obviously the hot code loading on the did fit side, and I was thinking it through, but obviously I got proved wrong before we got there.
Well, the hot code loading is a big selling point, right? I mean, you know, when I'm talking to people about our use of Erlang and they're not familiar with it, right? Maybe they've seen an article, blog post somewhere or something, right? And they're like, oh, that's that concurrent language, and you can do hot code loading in 9 nines, right? You know, and to come back and say, well, no and no, right? That kind of is a damper, right? It's a downer.
I don't think things are as grim as all that. But I would say that the managing hot upgrades on any kind of reasonable complexity of Erlang system is still at the, you know, spears with stone tips kind of stage.
Well, as you point out, it's a very manual process you do with the shell, so having any kind of automated infrastructure on top of it that doesn't let you just have a shell across every single node.
But that's the thing, like there's already some tooling around it, but the tooling doesn't seem to work for the kinds of apps that we want to run on PaaS environments. So like if you're building like software that comes in a box that is a computer, like a telephone switch chassis or whatever, then this stuff seems to work sensibly because you do like one hot upgrade every year, and you prepare it and you test it in advance, and it's worth the hassle. But if you want to deploy every time you get push, you can't write a rel up every time you get push. So we need something else, and yeah, like we need rebar for upgrades or whatever.
So it's the idea of hot upgrades, hot code upgrades is great. It's
right.
The execution of it's the problem.
Absolutely. Well,
and the small scale demo is brilliant.
Yeah. Well, it feels like the tools, the underlying tools, just aren't quite there yet, right? You could take and build another layer on top, like Rebar tries to do, that kind of orchestrates all of this stuff and gets it moving in the same direction. But it still feels kind of clunky. I think maybe if the underlying tools mature a bit, and that comes from people using it, people doing this, and coming back and saying, "Wow, this is really a pain point. We have to smooth that out."
Okay.
I think that's the end of that list. Do we want to? Anyone got any questions?
Yeah.
Comment though, more than a question. I mean, we're basically talking about two completely different things here. There's I'll call it small Erlang, which is I've got a server and I'm writing a client that hits a server and we're doing whatever, and that's your classic platform as a service kind of scenario. And then there's all the stuff that we've been talking about for the last 2 days, which is, hey, we scale like mad. Oh my God, check it out, 100 million scale thingy, whatever, which is the whole distributed, et cetera, and that's a different type of platform as a service, which I don't yet know that we're in a position to know what that means at this point.
I think there are aspects of the Erlang distribution that don't work great in the cloud right now, and some of those things are things like the way Erlang distribution protocol works. It makes all kinds of assumptions which aren't true, or are true only 99.9% of the time in the cloud. And that's actually one thing where I would like the Erlang runtime, like Erts, to be modified so that we can write Erlang distribution in Erlang. And I don't think that there are a huge number of things like VM modifications. I don't think there are a large number of those necessary to make that possible. And once people can experiment and try writing their own distribution carriers actually in Erlang instead of having to write a C driver, are you kidding me? My C code should never be loaded into an Erlang memory space. It's just, don't do it. Once we can experiment with some of those kinds of things, we can actually like shave all of these rough edges off to the point that you do come up with a set of tools and distribution and the other things that will let you run vastly more easily on something like a PaaS. So yeah, like I think if PaaS is improved to the point that you could run Erlang distribution right now, you could get to a certain cluster size with it, and it would be mostly reliable. It would be annoying in some cases where there's like transient network problems which occur on EC2 and PaaS providers. It just happens.
Kind of, sort of, but part of the issue with this is, and I'm just thinking of a couple of the talks that we went through today, Fernando's in the morning and working immediately after him. Anyhow, the point being that the things that you need to scale and the way you need to architect stuff for it to scale and the way you set up your system for it to scale is quite drastically different depending upon what you mean by scale. You add 3 zeros and all of a sudden, your architecture goes from this to that.
But I guess, I mean, as a PaaS vendor, if a client added 3 zeros, we would now have a large amount of money to work on it with.
Right.
So a lot of our customers are running apps that are decently large. They get reasonable volumes of traffic, but they're tractable volumes of traffic and scale and stuff at this point.
I think, there really is two kind of issues here, and the first issue isn't necessarily a PaaS-specific issue. It's almost like an IT management issue. It's like, how do we deploy these things easily? How do we manage, running applications easily? You solve that problem, right? Then Erlang in a PaaS becomes a much more doable thing. And then you start to talk about how can we take advantage of the real specific strengths of Erlang in a PaaS setting.
Is there any language or any framework that doesn't, when it goes into a PaaS environment, need to make compromises?
Oh, I don't think so.
Right.
Yeah.
Some of these, there are some compromises. Think about stuff that is developed recently, and this is, and I'm obviously baiting the group. Think about Node, something that's come after PaaS. There are compromises that are assumptions there, so you don't have some of the compromises that have been made, and some of the things that just haven't been accomplished yet with Node, because they're at the priorities, are things that we look at Node and we think this is crazy. But it's very effective and it's being adopted for lots of other reasons. When we were benchmarking an application, it's like there's no concept of back pressure. But it seems to have been fully adapted to an environment like this, and it makes very simple assumptions about distribution and network. And it's like, supposedly it's simple or like whatever.
There are some apps and some optimizations that you give up when you move to a PaaS because in the process of making your life easier, we make some choices.
So that's why and you talk about it a little bit with rebar, we're learning because we have to go across lots of different environments. We have to make, we started sort of idealistically with the notion that you could, that the environmental variables, actually the environmental variables that we face every day are changing even faster than they just continue to multiply. We've got OpenStack, we've got like all these different ways to manage, not just deploy the system. The PaaS is also often very deploy-centric in the way it frames the problems, but it's the operating environment is, the operating environment also has a series of important to understand compromises. They're not wrong, they're just compromises. You've traded, persistence to disk for another thing. And it's much easier to meter or to contain, or to have lots of different tenants, when you've made some of these compromises. But simplifying, the distribution of Erlang that works for a 5-node cluster on Metal might just have to be different and simple, and the choice is limited, and the distributions of Erlang that work on a certain class of PaaS with certain sorts of behaviors might just have to be different and simple. It's like rebar simplifies and takes away some choices. It's opinionated. It's not like take away choices. It's like be opinionated in the way that a really good hardware vendor is opinionated. You don't have 19 different choices. You have 3 choices, and they're the right choices, and you buy them, and you like it.
Constraints are liberating.
Yeah. So, the problem with that is a PaaS vendor also has to offer enough options to pull everybody in, the flavors. So it's a constant, but if the user experience, and we sort of have moved between talking about PaaS, like Erlang in the PaaS and Erlang on the PaaS. And, there's 2 different ways to look at it. So an operator for PaaS can be really opinionated because there's just, you're not having problems with Erlang for the things you're using, the clusters, right? Like the logging stuff. That's just straightforward stuff, right?
Yeah, so we would like to be able to run it on our own PaaS. Due to the networking thing, we can't. So we're running Erlang on EC2, which is like somewhere in the middle of the problem stack.
Yep.
And we've traded things like stable node identity and cluster membership for the ability to get machines to come and go rapidly.
That's kind of the whole idea of the cloud, right? Is that any instance is not guaranteed to be there. Right?
Every instance is guaranteed to not be there sometime when you really wanted it to.
Yeah.
It should actually be a really good thing for Erlang.
Well, but isn't that, go back to what where we started off, when we talk about platform as a service? Potentially there is, for somebody at some point down the road, there's a situation where we're not talking about instances that vanish, where we're talking about this Erlang infrastructure, this Erlang environment that's available, where you have stable node identity, where you have the ability to use amnesia. It's almost like it, but where it works, where you can do things, where you do get the scaling benefits. Actually, to take a step back on that one, a bunch of the advantages of Erlang for people in the past has been the scaling. But what I've noticed over the last couple of years is you're getting a lot more people who are using Erlang very specifically as single server and client, and that's it. There may be multiple instances of single servers that they're using, but it's still a single server solution. That's a different solution.
Yeah. And
I think we might have to wrap this up. I think we're pretty much out of time.
We should move this to the bar. We wanted to get originally anyway. We should have started this in the bar.
don't want
This
cameras
wasn't
in the bar.
exactly a debate to sort of beaten up Erlang. Thanks a lot. I'm turning the back, by the way.